Now let's dive further into using reduction formula of the form integral of sine raised power nx dx. And we recall in our last lesson that this is in is equals to minus 1 over n sine raised power n minus 1 of x cos x plus n minus 1 over n I subscript n minus 2. Now we have a question. The question says you should determine a reduction formula for this and then evaluate this. Now, we've done something similar to this before, in which the first thing we did was to find the reduction formula generally for sine raised power n of x dx from upper limit of 0 to pi over 2. Now with this, we know that integrating sine raised power n dx will give us in, and this is in here. So we apply that as minus 1 over n of x of sine n minus 1 of x cos x plus n minus 1 of over n of I subscript n minus 2. And we apply our limit from 0 to pi over 2. Now we notice that this doesn't have x variable, is a constant, so it can be brought outside such that the integral of the limit will be restricted to this. Therefore, let's apply our limits, our upper limits, and as well as our lower limits. So upper limits, we have minus 1 over n sine n minus 1 of pi over 2 cos pi over 2 minus the lower limit, which is minus 1 over n sine n minus 1 of 0 cos 0. And we'll have it added to n minus 1 over n in minus 2. Now, if you take a close look at this, and we understand that sine pi over 2 is equals to 1, and cos pi over 2 is equals to 0, we will see that this term nullifies to give 0, and likewise this term nullifies to give 0, because sine 0 is 0 and cos 0 is 1. So in short, we'll be left with n minus 1 over n in minus 2. So this is an expression for 0 to pi over 2 of sine raised power n of x integrated with respect to x. So therefore, the question we says we should evaluate integral of 0 to pi over 2 of sine raised power 6x dx. Now n in this case is what? 6, so that is I6. So substitute our n is equals to 6, and that will give us what? 6 minus 1 over 6 I into 6 minus 2. So that will give us 5 over 6 I4. So since we are applying now, this is in, we can easily evaluate I4, because I4 now will be what? 4 minus 1 over 4 I substitute 4 minus 2, which is 3 over 4 into I2. Likewise, we now evaluate I2, which is 2 minus 2 over 2 I substitute 2 minus 2, which will give us this is 2 minus 1. It should give us 1 over 2 I naught. Now let us evaluate I naught. We know that In is equals to integral of 0 to pi over 2 of sine raised to power n x dx. Therefore, our I naught, that means n is equals to 0, is equals to 0 integral of 0 to pi over 2 of sine raised to power 0 of x with respect to x. Now anything raised to power 0 is 1. So this is integral of 0 to pi over 2 of 1 dx, which is x from pi over 2 to 0. So I naught is equal to pi over 2 minus 0, which is simply pi over 2. Now we have an expression for I naught and we are going to I6. So let's begin to substitute. Substituting I naught into I2. So our I2 there will be 1 over 2 I naught, which will be 1 over 2 into pi over 2. And this will give us pi over 4. Then I raised for I4. That means we are substituting I2 into I4. And that is 3 over 4 I2. And 3 over 4 I2, that will be 3 over 4 into pi over 4. And this will give us 3 pi over 16. And finally, I6, which is our solved question, is 5 over 4, 5 over 6 I4. So I6 is 5 over 6 I4. So substituting our I4, we will have 3 pi over 16. And this will give us 15 over 96 pi. Since I6 is the question itself, that's 0 to pi over 2 of sine raised to power 6 of x dx. So using reduction formula, we have arrived at the answer. So having learned on how to integrate the form sine raised to power nx in respect to x, now let's learn also cos raised to power nx with respect to x. So we'll be using reduction formula for integrals of the form cos raised to power n of x dx in the next video.